Hey everyone, welcome to Broadband Deployment News. Vecima has launched or released 2 new nodes for DOCSIS 4.0, and they will be supporting PON as well in the future. Be right back. Thanks for joining me, Rick Husey here with Broadband Deployment News. So I wanted to talk about this. This is something that would be of great interest to cable operators that are looking at upgrading their plant to DOCSIS 4.0. So you see here, Vecima unleashes new remote PHY, MAC-Phy nodes for DOCSIS 4.0. This would also be of interest, I'm assuming, to fiber operators that are thinking about what competitive pressures they may have in their market, as they have had the upper hand, certainly on speeds. And DOCSIS 4.0 does allow cable operators, theoretically, to do symmetrical speeds, very high speeds, like 1 gig symmetrical, and even higher, maybe up to 6 gig symmetrical. That remains to be seen out in the field. But that's what that's going to support. So this would be for DOCSIS 3.1 as well as DOCSIS 4.0. Plus, these nodes will allow an operator to, if they put in, let's say, DOCSIS 4.0 technology today, they could then use that same node in the future for a PON deployment. They don't seem to be yet standardized nodes. I'll talk about that as well as far as gap nodes. But you see here, let's read through this, and then I want to share something about gap nodes just to kind of get you up to speed on what that is. So you see here, the title, this is in Fierce Telecom. Vecima is prepping for the wave of DOCSIS 4.0 deployments, announcing Thursday its 2 new 1.8 gig remote PHY and remote MAC-Phy nodes are now fully available on the market. So that 1.8 gig is important because that is going up to the very high splits required for extended spectrum DOCSIS if you're going to be doing that to get to higher speeds. Coined as forever nodes, they are designed to support existing distributed access architecture, or DAA. That would be like 3.1, as well as future technologies like DOCSIS 4.0 and remote optical line terminal, or OLT applications. So a remote OLT would be what you would have out in the field that would then serve something like GPON or XGS-PON, so fiber to the home. The nodes come in 2 flavors, EN8400 and SC-2D4, each having different form factors and can be used to support different use cases, according to Del Oro Group VP Jeff Hainan. I believe the SC has been used for remote OLT configurations, for example, he told Fierce. Vecima noted the EN8400 supports DOCSIS 3.1, remote PHY, and remote PHY, I guess. Oh no, DOCSIS 3.1 remote PHY, whereas SC-2D4 is tailored for remote MAC-Phy in the 3.1 system. So remote MAC-Phy and remote PHY, the difference there is they're both distributed access architecture, meaning it's pushing the services closer to the customer, getting fiber deep to the end user to reduce the amount of coax cable inside the cable plant, reduce the amount of RF problems that you might have. So they're trying to go fiber as close as they can to the customer. That gives them digital fiber as opposed to analog fiber to be able to do that as well on that segment. And then the difference is remote PHY is basically taking the physical infrastructure, the PHY meaning Phi, physical. It's not like FI, fidelity. So remote PHY is the physical layer, taking the physical layer out to the end user, or close to the end user, let's say, in a node. And then remote MAC-Phy is taking the MAC layer as well. So that, if you think about that, really it's like a little small CMTS that you're putting out in the field. So rather than having a big CMTS in the head end and you're serving that to lots of customers, you can put those remote MAC-Phy out in a node, hanging on a wire somewhere, for example, like you'd have other nodes, like a fiber node. And then you can serve a smaller number of customers, but again, it's like a little remote CMTS that's out there. So that's remote MAC-Phy. So there's operators are doing both. They've kind of started with remote PHY because that was the first standard, the really true first standard that was out. So they've been deploying those. That when you deploy one of those, it's called a RPD, or remote PHY device. Then when you put the remote MAC-Phy out in the field, that's a RMD, or remote MAC-Phy device. Ryan Nicomedos, SVP and General Manager of Vecima's Video and Broadband Solutions segment, stated the forever nodes are reducing the risk of our customers by providing a seamless and cost-effective path to whatever is next for them: remote PHY, remote MAC-Phy, DOCSIS 4.0, 10G PON, or beyond. So they call these forever nodes for that reason, that you could get this node, and then again you could put DOCSIS 3.1 in it now, and then you could upgrade to DOCSIS 4.0 in the future, and then you could go ahead and put in a remote OLT and do fiber to the subscriber. And I don't know if they support more than one at the same time. They may do that. There are nodes, I think, that are out or coming out that you can have, you could have an RPD in there, remote PHY device. You could also put maybe a remote OLT card in there. So you could, for example, selectively offer GPON to certain customers. If you want to, if you've got business customers, you could be supporting some with DOCSIS, some with fiber, have different levels of service. As cable access networks evolve to DOCSIS 4.0 and eventually migrate to fiber access, an investment protection strategy is extremely important to our customers, he said. Vecima joins the fray of cable vendors pushing out DOCSIS 4.0 compatible technology. Last week, ATX Networks unveiled its own 1.8 gig node, which is designed as a successor to Cisco's discontinued G7 or GS7000 platform. The difference between the ATX and the Vecima nodes, Hainan explained, and that's Hainan from the Del Oro Group, is the Vecima ones were created to address new deployments as well as serve as replacements for discontinued nodes. So it sounds like the Vecima is one that, again, will let you upgrade to fiber or put fiber in the node, not just the DOCSIS, whereas maybe the ATX doesn't do that. ATX nodes, on the other hand, are extending the life of existing GS7000s that many operators already have in their networks. So that one may not be able to, for example, provide fiber service directly from that node. You can imagine a scenario where an operator would want to use both vendors' nodes to replace outdated nodes, upgrade others, and deploy new nodes to reduce service group sizes and to address new service areas, he said. Charter Communications is one major operator leveraging Vecima tech for DOCSIS 4.0. Earlier this year, Charter struck a deal with Vecima to use its Entra remote PHY system for a 10G network upgrade. Building on their partnership, Vecima in September entered a warrant agreement with Charter, allowing the latter to purchase up to 3,661.50 of Vecima's common shares through 2031. So it looks like Charter invested there in Vecima. And it's interesting here that Hainan says you can imagine a scenario where an operator would want to use both vendors' nodes to replace outdated nodes. So in other words, you might use Vecima's for what you've got there, and then you might use the ATX one, but that still means you have two nodes. And what I don't read in this article is anything about a gap node or a general access platform enclosure or node. And that's a node that there's a standard out now from SCTE where you can put the standard enclosure, meaning that the dimensions of the enclosure are standard. There's a standard for all of the modules that go within the enclosure. And then if you have vendors like ATX and Vecima and CommScope and Nokia and Adtran and whoever, you've got all these vendors doing various things. Cisco, you've got DOCSIS equipment. You could put modules in those standardized gap nodes, and it doesn't matter who the vendor is. So that way you don't have to have different enclosures. That's the real thing, is you don't have to have different enclosures sitting on the shelf for different pieces of equipment that you want to put out in the field from different vendors. So it doesn't mention that here, but interestingly enough, Vecima is one of the first, and if not the first, they say they are, that came out with a gap node. But first, we'll look at this. This is this again here you see driving the DAA or distributed access evolution from traditional HFC to all digital Ethernet, the Entra distributed access platform, DOCSIS 3.1 solutions, but you'll see here full spectrum DOCSIS 3.1. The EN8100 delivers maximum DOCSIS 3.1. Let me make that a little bigger. EN8100 delivers maximum DOCSIS 3.1 throughput with full spectrum support up to 1.2 gig and downstream and 2.4 megahertz upstream, while the EN8400 is designed to support future D4 DOCSIS 4.0 operation up to 1.8 gig. So you see the EN8400, that's the one that we're talking about in the article that's going to be supporting the DOCSIS 4.0. And again, they call this future-proof access or forever node because you've got DOCSIS 3.1, remote MAC-Phy today, and remote MAC-Phy today, or remote PHY and remote MAC-Phy. Then you've got DOCSIS 4.0 and remote PON, OLT, and carrier Ethernet in the future. So right today, what they've announced is this DOCSIS 4.0 capability at the 1.8 gigahertz. But again, what they had already announced was their gap node. So you see the Vecima E9000 gap node is the world's first commercially available general access platform gap node. And again, a gap node is standardized. So you should be able to use any vendor equipment in there, if they develop a module that would be compatible with what should be a standardized gap node. So you know all the dimensions of what your module is supposed to be, you know what the power plane and back plane all look like, all of that. And you just develop your modules to fit in there, and then Vecima could provide this gap enclosure out there, and they can put their operator could put their modules in there, like a DOCSIS RPD in there, or a remote OLT, or anybody else. Like somebody could take let's say if Nokia developed something for this gap platform, then they could put a Nokia fiber out there. Maybe they use the DOCSIS RPD from Vecima, but they use a Nokia OLT. So that is the beauty of a gap node. Again, you don't need to have different enclosures from different manufacturers and then have multiple things hanging on a line. You just have one enclosure that looks like this. And there is a standard here, again, SCTE. So I've linked to all this stuff. I linked to the Fierce Telecom article. I linked to, I believe I linked to that. I think I might have linked to that. And I know I linked to this. So this is the SCTE standards right here that you can download. So you see there's a gap standard for the enclosure. Again, that's the metal enclosure, the modules that go inside it, and the integrator best practices or something about that. To give you an example of the gap platform, where did I put that? Right here, I think. Yeah. So here you've got a gap platform, and this is straight from the SCT specification. So you see you've got a standardized kind of bottom right here. You've got a bottom, a base, and then you've got a lid that goes on top of it. So you see this is kind of the standardized base right here, full-size base module. And these can actually be in different configurations. This is a full-size module, but you could have smaller modules in here. So maybe this would be big enough, for example, to put in a remote MAC-Phy or an RMD, meaning the little small remote CMTS or a remote OLT. And maybe you can have smaller ones for RPDs. I'm not sure exactly how that works out, but you can have different sizes here, different standard sizes. So this would be the full size one right there. And then you've got, let's see, can I get this to, there we go. So, and this would be kind of the standard as far as the enclosure. So again, you've got standard dimensions. So that's really important that you've got that any manufacturer that's going to be creating modules for this knows exactly what they're getting as far as what the dimensions are inside and outside. Very important. Then you can see here, here again is another example of this would be one that's got different size modules in here. You've got 4 different modules, but again, standard sizes, standard power. You've got your lid, different modules that can go in there. So again, this is all the, actually I'm going to go back to here just so we can see this. That's all of the standards from this SCTE document right here. So I didn't link to this document, but it is available if you go, where was it? Right here, where I was talking about if you download the standard enclosure specification, you can then see what this looks like if you want to do some light reading this weekend. It's only, how many pages is it? Only 69 pages of very technical stuff. So you can see here, there's a lot in here. It's about, shows you, information about the base and the lid, how to, interoperability principles, the dimensions of everything, from, dimensions of the enclosure, the hinge, sealing bolts, the finish, corrosion resistance, all supposed to be standard. The base gasket location, the base module areas, the power supply areas, the backplane mechanical stuff, backplane electrical, all needs to be conforming to the standard. And once that's done, then again, that will help cable operators greatly, because then cable operators will be able to take that information, take that standardized enclosure, buy that, and they can have that on the shelf, and they can then take that and put it out, and it doesn't matter what the equipment is that they want to put in that enclosure. They can put that out in the field, they can drop some equipment in, then they can get some other equipment later, like a standardized OLT that will fit in that gap node. They can put that in. They don't need to change out the node. They can have multiple things in the node supporting different technologies. So it really is a great option for cable operators as they look to the future on what they're going to be doing, because we do know lots of cable operators are looking at, upgrading their plants. Some still might be on DOCSIS 3.0 looking to go to DOCSIS 3.1. smaller operators. We've got operators on DOCSIS 3.1 going to DOCSIS 4.0. So they're looking to the future there to try to keep their HFC plant up to speed so that they can compete with fiber. They won't be able to get, at DOCSIS 3.1, they won't be able to get the symmetrical speeds that fiber operators can provide, but they can get higher download and upload speeds than they were providing before if they do mid splits and high splits in that route. And then they can go to DOCSIS 4.0 and get even higher speeds and splits from that. And they can do full duplex if they want to do duplex services, I was mentioning, where they can do symmetrical speeds. But they're all looking past that to the future to get to fiber because they know fiber is where it's at. They know that's the future, but they're not ready to take out all of the investment that they have in their last mile infrastructure because that's the really expensive part. You know, they could today upgrade customers to DOCSIS 4.0 and it might cost them a couple, $200, $300, $400 per home passing. I'm not sure what it's all going to wind up. And then I don't think they even need to put a DOCSIS 4.0 modem in the subscriber home to do that because everything's pretty standard. But obviously, if they're going to upgrade the CP, that's a cost as well. But that would compare to maybe $2,000, $3,000 or more to upgrade to a fiber to the home kind of thing. They've got to put the fiber in the last mile. They've got to definitely got to upgrade the CPE. They got to do other kinds of things in the home. So it's much more expensive to do that. So they're going to try to get squeeze the most they can out of their DOCSIS plant. And then they are all looking to the future for fiber. If they're deploying in a greenfield area, they're doing fiber. If they have a very competitive situation, they might overbuild themselves with fiber. If they're edging out, they might go one way or the other. They might say, well, we can get DOCSIS out there pretty quickly and inexpensively. But if they are going in a new area that's very close to them, they might, again, if it's greenfield, they're very likely going fiber. They're used to doing fiber already, right? Because they got to go fiber deep now as they do these remote PHY and remote MAC-Phy deployments. So they're used to deploying fiber. Now they're just taking that last step, that last mile to the end user subscriber if they don't have service there already. So thanks for joining me. I hope this was helpful. If so, if you give me a like on the video. If you haven't subscribed to our channel, click the subscribe button, click the bell, and you'll be notified when I'm live. I'll see you next time for Broadband Deployment News. Take care.